Hey, mathletes. In this video, what we're going to look at is what's known as the quotient rule. So what we've learned so far is the power rule. We've learned the sum and difference rule, so adding and subtracting. We learned the product rule, multiplying. So guess what? Let's do some division. Okay, again, I'm just going to give you the rule instead of doing an investigation. And here's how it goes. So we are going to take the derivative of two functions that are being divided. What we end up with is something a little bit more complicated than the product rule. It goes like this. The bottom function multiplied by the derivative of the top minus the top function multiplied by the derivative of the bottom all over the bottom function squared. So again, I mean, that's what it looks like as a rule. I prefer just to use words. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And I know I should be using the terms numerator and denominator, but that just makes it sound more complicated. That's it, friends. There's your rule. We just need to apply it. Where this gets tricky is the simplification, not in applying usually the product rule itself. Let's just do two examples. That's all you need to see. So let's take the derivative of f at x. So the derivative of this, it's the bottom, x plus 1, multiplied by the derivative of the top, which would just be 1, minus the top times the derivative of the bottom, which is just 1 in this case. This is an easy example to start, all over the bottom squared. Now let's simplify. So in the numerator, I'm going to get x plus 1 minus x plus 1, right? Distribute that negative through, and I'm going to leave the denominator factored. We're big fans of leaving things factored. That's going to help us when we're in curve sketching. And I see my x's add to 0, and there it is. There's the derivative of two functions that were divided. So like I said, this one wasn't too bad, right? It wasn't too cumbersome. But what's going to start happening as we're doing these is it's the simplification that can get a little bad. All right, let's try just one more, and that should take care of pretty much everything we need to do. And then it's just applying the rules. So here we go. The derivative of f at x is the bottom multiplied by the derivative of the top minus the top times the derivative of the bottom, which is 2x, right? So you see how we use that power rule nonstop over the derivative, or over the bottom function, the denominator squared. Okay, let's do some simplification in our numerator. So again, the denominator is factored. I'm happy. I leave it. In the numerator, 2x squared plus 2. Now, here in this subtraction, this is where I'm going to start seeing mistakes. So notice what I'm going to do. I'm going to make a big square bracket, and I'm just going to multiply these two things first, like that. And the reason why I did that is because what I'll see when students are first learning the quotient rule is they will mess up distributing this negative right here. And they'll forget that that is going to change that sign. So 2x squared plus 2 minus 4x squared. And like I just said, a lot of students would then tell me minus 2x. So that's why I like to put those brackets in. But we know it's plus 2x. Okay, collect any like terms we have. Well, what have we got? We're going to have negative 2x squared plus 2x plus 2 over x squared plus 1 all squared. Now, what I want you to do from here is say to yourself, is there something else we can do? Can we do some more factoring, some simplification? In the numerator, what I want to do is factor out a negative 2. And there's what I'm going to get. Now, on a more complicated question, what would happen is this here might factor and then simplify with our denominator. So it's really, really important that we're constantly checking our factoring at the end. Okay, that's the simplification piece that might start to get complex in these questions. So again, now what do we know? We now know how to take the derivative of when things are added and subtracted, when they're multiplied, when they're divided. We've got one last major rule. That's really not true. Two major rules in this unit to take care of. What we need to work on is how do we take the derivative of composed functions? This will be the trickiest lesson. This is called the chain rule, and we'll talk about that very soon. Here we are, my friends. Not so bad. See you next time.